Okay, so there will be some times where you have to find a derivative of a product, right? So you have two differentiable functions that are being multiplied. So if f and g are differentiable, then their product is also differentiable, and you use the product rule to find the derivative. So the way this works is, let's say you had to find the derivative of f of x times g of x. The rule is then that derivative is equal to f prime of x times g of x plus f of x times g prime of x. So basically you're finding the derivative of each one and multiplying it by the original function and then adding those together. Sometimes you'll see it written like this just because it's easier. You set one function equal to u, you set one function equal to v, and it's u prime v plus v prime u. And that's the way I'm going to do it because it is easier for me to remember. So here's an example. Here's a function. It's x squared times 2x minus 2. You are going to feel inclined to just say, oh, the derivative of x squared is 2x, and then times the derivative of 2x is just 2 minus, no, you cannot do that. This is a product of two different functions. You must use the product rule. So essentially we're saying f of x is x squared and g of x is 2x minus 2, right? Those are two different functions, but I'm going to use this uv notation. So I'm going to set u equal to x squared, and then I'm going to set v equal to 2x minus 2. So then now underneath it, I'm going to find the derivative of each of those functions. The derivative of x squared is 2x. And the derivative of 2x minus 2 is just 2, right? Because I take the 1 down, that's times 2, 1 minus, yeah. And then the second part's 0. Okay, so now let's find the derivative. So f prime of x is equal to u prime times v. U prime is 2x. V is 2x minus 2. Plus v prime, oops, I forgot to label that v prime. V prime is 2 times u, x squared. Now it's just a matter of simplifying all of this. This becomes 4x squared minus 2x plus 2x squared. So f prime of x is equal to 6x squared minus 2x. Oh, this is 4x. I'm noticing that 2 times 2 is 4. Arithmetic error. Okay, so let's try that again. Let's throw a trig function in there. So here are my two functions. I'm going to call this part function 1 and this part function 2, f of x, g of x, right? Or u and v. So if I make u equal to 3x cubed, then v has to be sine of x. So u prime is equal to 9x squared, and v prime is equal to cosine of x, right? The derivative of that is here, the derivative of v is there. So now I'm just using my product rule to say f prime of x, and the way I do it in my head, I don't necessarily remember u prime v, v prime u. I just remember that I have to multiply that, and then add them. So I multiply along the crisscrosses. That's how I remember. So, and this is backwards, so it doesn't really matter the order, but I'll go the same way. U prime v. So 9x squared times sine x plus v prime u, that's cosine x, and 3x cubed. So now we simplify. There is no simplifying. I'm just going to rewrite it like this. Okay? All right, one more. Two functions. I'm going to make the first function u. This one's easy to see. They're in parentheses. My second function v. U prime is 3x squared, and that's minus 0. I don't need to worry about it. V prime equals 0, negative 3. So let's just go across the diagonal. So f prime of x equals these two plus that way, put the negative 3 first. Okay, so now when I simplify, that's 6x squared plus, minus 9x cubed minus 3x cubed plus 12. I can simplify more. So f prime of x equals, I can combine these, negative 9x cubed. Yep, and so that's minus 12x cubed plus 6x squared plus 12. You guys let me know if I have an arithmetic error in there. I think I did that right. 6x squared minus 9x cubed. Yeah. Okay. Now let's do one that has some context. The position of a particle is given by x of t equals t squared minus 4t, all of that times cosine t. Find the velocity of the particle when t equals pi over 2. So we're finding derivative at a point. So step 1, I'm just going to rewrite the function here. So the first step is to find the derivative of this function, okay? Let's break them up. We have to use the product rule here. So u prime is 2t minus 4, right? V prime is minus sine t. So x prime of t is going to be u prime v, so I'll go this way, plus the other diagonal. Now we're just simplifying a bit. This one, I'm actually just going to leave this like this over here. And then this one, I'm going to just move it, the sign to the front, like that. Okay? Because we need to evaluate it when t equals pi over 2. So x prime of pi over 2 is 2 times pi over 2 minus 4 times cosine of pi over 2 minus sine of pi over 2 minus pi over 2 squared minus 4 times pi over 2. Okay, so I'm evaluating all this. These cancel out, so this part is just pi minus 4. What's cosine of pi over 2? Who remembers that? Cosine of pi over 2? 0. Minus sine of pi over 2? 1. And then this thing becomes pi squared over 4. And that goes away, and you just have 2 pi, I believe. So now if I simplify all of this, x prime of pi over 2, this whole thing goes to 0, so that's gone. It equals negative pi squared over 4 minus 2 pi, which means that's, let's rewrite it as negative pi squared over 4 plus 2 pi. Well, let's just leave it as that, okay? So x prime of pi over 2 is equal to this. And remember, the derivative of a position function is the velocity function. So this x prime of pi over 2 is the same as the velocity at pi over 2. Okay, so the velocity at pi over 2 is equal to the derivative of the position function at pi over 2, which is this right here. We can put it in our calculator and get some decimal, but we don't need to. That's good enough. Okay, product rule. Hopefully you know what's coming next. Not multiplication, the other one. See you in the next video.